In this video, I'm going to be solving a coding challenge created by my friend. The goal is to optimize a poorly performing Entity Framework query to make it execute faster. The coding challenge is still active, so I invite you to give it a try and submit your solution. I'm going to leave the GitHub repository where you can find the details about this challenge in the description of this video. First, I'm going to explain what the coding challenge is and what are the rules, and then I'm going to guide you through my thought process as we optimize this query step by step. The comment right here describes what is the exact result of this query. We need to return the top two authors ordered by their book count, where the country is Serbia and they are 27 years old, and we also need to include all of their books that they have published before the year 1900. I'm going to walk you through the baseline version of this query, which is going to be the starting point for our optimization. We are creating the Entity Framework database context, and then we are querying the authors collection. We have a few include statements to related collections. Then we have a select statement here. This select statement returns a new author DTO with all of the relevant information required for this query. After the select statement, we have some filtering. Here we are filtering that the country of our author is Serbia and that his age is equal to 27. And after applying this filter, we are calling toList, which is going to return the authors from the database. Now that we have the authors collection in memory, we are sorting in a descending order by the book count, and then we are taking the top two authors because this is the requirement of our query. The last part that you can see here is the filtering on the books. If you remember, the requirement is that the books were published before the year 1900. And after everything has been applied, we return the final list of authors. Alright, now that you have a better idea of what this query looks like, I'm going to start optimizing it step by step, and we'll see how much we can improve on the baseline solution. The first thing that I did behind the scenes was I updated this project from .NET Core 3.1 to .NET 6, which is going to give us a lot of performance improvements on its own. So this is kind of the first step in our optimization, and now we're going to dive into actually optimizing this query. To say that there are a lot of things wrong in this query would be underplaying the solution, but let's start one by one. The first thing that I'm going to do is get rid of these intermediate toList calls. What this call is going to do is it's going to return all of the records from the database before applying the select statement here and before applying the where statement that we have below. So it's very important that I get rid of this so that we are only fetching the data that we need from the database. So I'm going to delete this here. Let's see if there are any more that I can get rid of. This one here is also going to load all of the records from the database because it's applied before the where statement. So I'm going to delete it. With these two changes, I'm going to run the benchmark and see what is the improvement that we got so far. And the results are in, and unsurprisingly, our optimized getAuthors method is 54.46 times faster than the baseline version. So what I want you to get out of this is never call toList and load all of the records from your database. Only load the records that you need to satisfy the query. I'm going to keep track of this performance multiple throughout this video to see how we compare to existing solutions. I think that the best solution so far is 230 times faster than the baseline version, and let's see if we can do better than this. The previous change allowed us not to load all of the authors from the database, but if you take a look here, you will notice that we only really care about the top two authors by the book count, which means that we are still loading all of the authors that satisfy this where condition here, and then taking the top two. The better approach would be to let the database do the heavy lifting. So I'm going to copy over this order by call after our where statement, and I'm also going to copy the take two statement below it. So what's going on now is we are executing our where statement. We are sorting by the book count, and then we are taking the top two authors. This means that we are going to be returning the top two authors from the database, which is exactly what we want. So we can get rid of this ordered authors variable, and we have to fix this query here. Let me just do that. Alright, so after making this change, I'm going to run the benchmark again and see if we got any performance improvements. The results are in after this change, and now that we are only loading the top two authors directly from the database, you can see that we have a 185 times improvement over the baseline method, which is amazing by itself. We are already a lot closer to the best performing solution. Let's see what we can do next to improve this even more. The changes so far were focused on moving the heavy lifting and the filtering into the database. If you recall at this part of the code here, we are filtering on our books to check that the publishing year is less than the year 1900. This is something that we can also move to the database. We can do that right here, where we are selecting our list of books by adding a where statement before selecting the book DTO, and this should apply the filter at the database level. I'm going to move the select statement into a new row, make this indentation a bit better, and I need to filter on the books collection, and I'm going to check that the book year is less than the year 1900. So we need to access the published on date and time, check that the year is less than 1900, and this should satisfy the condition that we have below. And now we can safely get rid of the code that we have underneath because it's no longer necessary. I'm going to remove this code, return the authors here, and let's run our benchmark again to see how much improvement we got from this change. So the results are in, and after this change we actually got a performance regression. We're now only 156 times faster as opposed to the 180 something that we had a moment ago. So this change actually causes a performance regression, but I'm going to leave it like that now because I still want to load the least amount of possible data from the database. If you take a look at what I did so far, my main focus was on reducing the amount of data that I return from the database. But if you recall, and I'm going to scroll up here to this comment describing what this method is supposed to return, if you pay attention to what it says here, it says that you need to return the first name, last name, username, email, age, and country. And for the book, you need the name and the publishment year. What this actually tells me is that we are returning too much information in our author DTO. So this is going to be the next step in my performance optimization. I'm going to get rid of all of these unnecessary columns here. The user created, email confirmed is not necessary. The first name is required. The last activity I'm going to get rid of. Last name is required. Email is required. Username is required. The user ID and the role ID is not required, so I'm going to delete them. The books count I'm going to leave because we need it for the order by statement. We still need the books here, but we only need the name and when it was published. So I can get rid of these two fields here. We need the age and the country of the author, but I can get rid of the nickname. So after getting rid of all of these unnecessary columns that are returned from the database, let's run our benchmark again and see if we got a performance improvement from this one. And we got our benchmark results back, and as you can see, we are almost 180 times faster. So we're almost back to our best performance multiple, which was 185 times faster. So now let's see what we can do next to make this perform even better. We slimmed down the response from the database as much as we could, and now we are only returning exactly the data that is required for this query. Before proceeding with additional performance improvements, I'm going to get rid of these include statements here because they don't add anything useful for this query, and the query can execute just fine without them. Deleting them is not going to yield any significant performance improvements, so I won't be running the benchmark again. But I do want to see what I can do now to optimize this even further. One thing that you can do to improve the performance of your read-only queries is call AsNoTracking with the database context. This is going to tell Entity Framework not to track the response return from your query in the change tracker, and it's going to give you noticeable performance improvements whenever you are loading your actual entities from the database. Why am I stressing the entities part? If you take a look here, we are returning the author DTO class, and the author's DB set is of type entities author. In this case, calling AsNoTracking here is not going to give you any performance improvement at all, because when you are projecting the result from the database into a non-entity class, it's going to be not tracked in the change tracker by default. So in this situation, calling AsNoTracking is not going to give us any performance improvement, so I'm going to remove it. What we did so far was relatively straightforward, but now we have to work a little harder to see if we can squeeze out a bit more performance out of this. If you take a look here, we are returning the books count from the database. The only reason for this is so that we can sort on this property later in the query. What I can do is move this order by statement above here before the select statement, and now I can get rid of this line here, and I don't have to return the books count from this query. And I think this is going to give at least a slight performance improvement, so I'm going to check that right now. The results are in, and we did get a slight boost to performance. We are now 181 times faster than the baseline method. Even though this change was minor, we still got a slight performance improvement, and I'll take that any day of the week. Let's see what we can do next. Since we move our order by statement at the top here, I'm going to move the where statement just above it because it feels more natural to write my query like this. I need to fix the country here and the age so that everything compiles. The order of placing the where statement in a LINQ query is not going to significantly affect the execution of the query as a whole, so it makes no sense to run the benchmark again. We won't see any noticeable improvements. So what are we going to do next? I'm going to use a feature that was introduced in Entity Framework Core 5.0, if I recall correctly, and the feature is filtered includes. It works like this. You specify an include statement and tell it what property you want to include. In this case, I want to include the books, and I want to apply a filter on this collection in the include statement, which I can do. I'm going to say book where the published year is less than 1900. And now that I have my where statement here, I can get rid of the filter that I have inside of the select statement here. So let's see if the filtered includes feature is going to give us any performance improvement. I'm going to run the benchmark and we're going to discuss the results. The results are in, and we got a major improvement from making this change. We are now 227 times faster than the baseline unoptimized method. So the filtered include that I just applied made a noticeable difference, and now we are almost at par with the best solution, which was 230 times faster than the baseline. And my guess is that that solution is pretty similar to what I have going on here. Let's see if I can squeeze out something more from this query so that we end up being faster in the end. One other feature that was also introduced in EF Core 5 is query splitting. Query splitting tells Entity Framework to not generate a single SQL statement when transforming your LINQ query into SQL. In this case here, what Entity Framework is going to do is it's going to load authors and books in one SQL query. And if we specify as split query here, we tell Entity Framework to generate separate SQL statements for fetching the authors and for fetching the books. The downside here is that these queries cannot run at the same time. They have to be executed one by one. So what this means is more round trips to the database. So I'm going to run the benchmark here, and I expect the performance to be noticeably worse, but you never know. The results are in, and as I suspected, the performance is worse than what we had before. We are 165 times faster as opposed to the almost 230 that we had just a moment earlier. So query splitting is not a good option for this situation. So I'm going to get rid of it and see if I can think of something else. If you are liking this performance optimization video so far, make sure that you leave it a like and also subscribe to the channel before watching the rest of the video. With all of the changes that we have applied so far, I think that we have reached the limits of what Entity Framework can offer us. The additional changes that we can do would be add indexes to the database. Specifically, we can add an index on the published on year. We can also index on the country and the age on the authors table, and this is going to give us a noticeable performance improvement when filtering these records. Also, you could introduce a caching layer on top of this if this data is relatively stable and doesn't change that often. I'm going to run the benchmark one more time for good luck because our machine is nicely warmed up from executing all of the previous benchmarks to see if we can get a slightly better performance multiple than what we had so far. The results are in, and this is the best benchmark that I got today. We have a 233 times improvement over the baseline unoptimized method. I'm pretty happy with the performance improvements we managed to squeeze out of Entity Framework in this situation. If we wanted to make this query even faster, we could probably do that by writing it in raw SQL and executing it with something like Dapper, but that's against the rules of this coding challenge, so I'm going to leave that for another time. I really hope that you enjoyed this performance optimization video, and until next time, stay awesome.